Okay, in this video we are going to do a lot of algebra. It's going to involve exponents, rational expressions, difference of squares, simplifying things, and it's all based on two quiz questions that I gave at some point. So let's take a look. So write each of the following as a single fraction in factored form. Your answer should only have positive exponents. So the first thing we're dealing with is the quantity x times y to the negative first minus y times x to the negative first times the quantity y times x to the negative first minus x times y to the negative first. So let's dive in and see what we can do. First thing I'm going to deal with is all those negative exponents. So they're all currently in the numerator of their respective fractions, so I'm going to move them to the denominator with a positive exponent. So let's see. So we've got the quantity x is going to stay where it is. That y goes into the denominator. Minus y is going to stay where it is, and x is going to go into the denominator. So I'm kind of color coding them so you can see the algebra as I simplify things. And we're going to do the same thing here. So we get y over x, and then minus x over y. All right, so we have this, and now what I want to do is get a common denominator. So I'm going to treat each quantity as its own sort of separate problem at this point. So this first quantity, I'm going to end up with x times x, and then minus y times y, and then all over x times y. So you might not actually show this step, you might just simplify it to the next step, but that's okay. And let's deal with this quantity. So it's going to be y times y, and then minus x times x. So you can kind of follow the color of the variables if you're wondering where these things are coming from, and then x times y. All right, and so I'm actually just going to simplify this. So that's x squared minus y squared over xy. And it also lets me kind of reset the colors that I'm going to use going forward because there's kind of a limited number. Okay, so we have this. And there's not much to do at this step. So you look at it, I'm just going to keep the x minus y squared, x minus y squared, x squared minus y squared, that was hard to say, times y squared minus x squared. And so I'm trying to write this all as one fraction. So I see xy here and xy here, and I'm multiplying. So I actually multiply those. So it's going to be x squared, y squared. All right, so pretty simple. Now what I'm going to do is take a look at this because I have a y squared minus x squared, and that's actually equal to the negative of x squared minus y squared. So just factor out a negative 1, I guess. And if you try distributing that, you'll get back to negative x squared plus y squared, which is definitely the same as y squared minus x squared. So I'm actually going to use this fact to rewrite the fraction that I have. So I'm going to keep my x squared minus y squared. I'm going to replace the y squared minus x squared with the opposite of the quantity x squared minus y squared. And then keep the denominator over x squared y squared. So now I'm going to factor out that negative. So it equals negative. And if you look, we have x squared minus y squared times x squared minus y squared. That's the quantity. X squared minus y squared squared. And then that's still over our denominator. Okay, but the directions say we have to write our answer in factored form. So this is like pretty simplified, but it's not factored because x squared minus y squared is actually a difference of squares. So I can factor it. So this will be the quantity x plus y times the quantity x minus y. But that's still sitting in a set of parentheses, and it's squared. And then all over that denominator. We finished the denominator a while ago. And then I'm kind of done, but I have a product to a power, so I want to rewrite it as each of the factors raised to that power. And there you go. So we had some negative exponents. We had to get common denominators. We had to then multiply fractions, use that weird property. It's actually a really commonly used property that y squared minus x squared is the negative of x squared minus y squared. And we got it simplified. Let's take a look at the next one. All right, so we have the quantity x to the negative second minus y to the negative second, all to the negative third, over the quantity x squared over y squared minus y squared over x squared to the negative second. So these kinds of problems are really just for practice with all the various skills that you know. So let's see if we can do it. First thing I'm going to do is deal with those negative exponents that are kind of like on the outside. So I'm going to look at this thing. It's in the denominator with a negative exponent, so I'm just going to move it to the numerator with a positive exponent. So that's all I'm really going to do in this first step. So I'm also going to color code things so you can kind of follow the work. So it went to the numerator with a positive exponent. Then I'm going to do basically the same thing with this. The original numerator has a negative exponent, so I'm just going to bring it down. I get x to the negative second minus y to the negative second, and then to the positive third. All right. So looking at just the numerator, what I want to do is get a common denominator, and I'm actually not really going to show the work here. It's just going to be x to the fourth minus y to the fourth over x squared y squared, and then the whole thing squared, over, I'm just going to keep the denominator for a while and work on the numerator. All right, so in the numerator, I have a quotient being raised to a power. So what I want to do is take the numerator of the quotient to that power, and then the denominator of the quotient to that power. So when you have a quotient to a power, both the numerator and the denominator get to use that power. So we have this over, and now we're going to have x squared y squared squared. And then all over, I'm just keeping the denominator. All right, so my numerator is like kind of done for now, so I'm going to actually keep the numerator as it is and deal with this quantity in the denominator, so the thing that's to the third. So I'm going to make this 1 over x squared minus 1 over y squared to deal with those negative exponents and leave this whole thing to the third. And so I'm not going to change the numerator, so I'm just going to copy that down. Going to get a common denominator within the parentheses that are in the denominator. So basically treat the denominator as its own problem at this point. So that's going to be y squared minus x squared, and then all over x squared y squared. And you can follow the colors if you want, or if you're not sure where things are coming from. Again, we have a quotient raised to a power, so we're going to keep the numerator and deal with it. So the numerator here in the denominator gets to be to the third power, and the denominator in the denominator gets to be to the third power. So we'll end up with x squared y squared to the third. And we're getting there. So I have a fraction divided by a fraction at this point. So there's my overall numerator. There's my overall denominator. So what I'm going to do is I'm going to multiply by the reciprocal. So keep the numerator. So I'm just going to keep this. I'm also using the power to product to a power. So x squared y squared quantity squared is x squared squared, which is x to the fourth, y squared squared, which is y to the fourth. And now I'm multiplying by the reciprocal of the original denominator. So I'm going to use the product to a power rule again. So I have x squared cubed, which is x to the sixth. I have y squared cubed, which is y to the sixth. And then all that's going to be over this quantity here, y squared minus x squared cubed. All right. At this point, I'm going to use a kind of relevant fact. So the relevant fact is that x to the fourth minus y to the fourth is the same as the opposite of y to the fourth minus x to the fourth, which should look familiar because we did something like this on the previous problem as well. But in this case, I also want to note that x to the fourth minus y to the fourth squared is the same as y to the fourth minus x to the fourth squared, because when you square the negative 1 that's a coefficient, you just get positive 1 again. So that means that I can kind of make a substitution. So if we look, we have a x to the sixth, an x to the fourth in the denominator, and x to the sixth in the numerator. So that simplifies down to just x squared. We have the same thing happening with y, so we have those. So that's just going to be y squared. I'm going to replace the quantity x to the fourth minus y to the fourth squared using this relationship. So I'm changing the color so that you can follow what happened there. And then all over the x to the fourth and y to the fourth canceled, so all that's left in the denominator is this quantity here. We're almost done, but not quite done. So what I'm going to do is copy what I have to a new page and just keep going. So this is what we've gotten to. And if you look, y to the fourth minus x to the fourth is actually a difference of squares. So what I'm going to do is I'm going to factor that. It's y squared squared minus x squared squared. So that's going to factor into y squared plus x squared times y squared minus x squared. Although I decided to write them backwards this time. It doesn't really matter though, because of commutative property, you can write them however you want. But that whole thing is still squared because I only factored the thing inside. That squared on the outside is still there. And then over, I got like 3 more steps and I'm going to be done. Over that, so I have a product to a power in the numerator there, so I'm going to actually use that. X squared minus x squared, squared, and y squared plus x squared, squared. And then over that denominator. So I want to look at this, and before I see difference of squares, but before I do that, I see y squared minus x squared squared in the numerator, and y squared minus x squared cubed in the denominator, so I can actually simplify that. So I'm definitely going to do that. So x squared y squared, the y squared minus x squared squared is going to cancel, and I'll just be left with y squared plus x squared squared. These things are kind of annoying to read. And then in the denominator, since I canceled 2 of them, I still have 1 factor of y squared minus x squared. That's a difference of squares. So to finish the problem, I'm going to factor that, and I'll be done. So x squared, y squared. The quantity y squared plus x squared squared over, factor your difference of squares, quantity y plus x times quantity y minus x, and we're done. And you might not even remember the original problem right there is what this is equivalent to. So it's just a ton of algebra. There are a lot of places you could make a mistake, but if you're careful about it, you won't make those mistakes. And that's kind of the idea. Get good at doing these things. I hope you found this helpful, and good luck.